Good evening, you all. Lightning is a major matter in Sri Lanka because we are actually.
Does the participants, online participants, get the sound?
Yeah.
Check the sound.
In Sri Lanka, we have very big trouble with lightning because we are having number of lightning per day sometimes. Isocurrent level is very much higher, maybe greater than 100 in some cases. So lightning protection system is now essential because now we are using comprehensive electronic equipment in our household. Sometimes we are going for rooftop solar systems. Therefore, lightning protection system and surge protective devices are very important once we come to domestic and industrial applications. So that is why we thought to have a good awareness sessions on lightning protection system and surge protective devices. On behalf of the Electrical, Electronic and Telecommunication Engineering Sectional Committee, we are conducting this awareness session with the sponsorship of Cafe Electric Private Limited, India. So, to welcome you all, I am cordially invite Chairman of Electrical, Electronics and Telecommunication Sectional Committee Chairman, Engineer Chamil Edirumani. Over to you.
Thank you, Engineer Navodana. Good evening, ladies and gentlemen. This is another will be an important event in the part of electrical safety. Resource person, Mr. Gopakumar, I think if you have been able to attend our last lecture, which he had actually conducted, so you may have got a lot of education with his excellent teaching abilities. So I must welcome Mr. Gopakumar, Managing Director, Cape Electric Private Limited, for accepting our invitation to become the resource person for the second time. And also Chairman, Engineer Tilak Silva, Engineering Council. So I welcome you, sir, for gracing this occasion coming physically. Thank you very much. And past President, Engineer Chula Silva, CEO, Engineer Neil Abesekara, and Engineer Navodana, Vice President, and all the committee members of the Engineering Section Committee, and other engineers. So I welcome you all, and I must need your full attention on this special lecture so that Mr. Gopakumar will be conducting for the benefit of Sri Lankan electrical engineers. Thank you very much. Over to you, Mr. Gopakumar.
So I hope the sound is clear for all the audience, those who are connected online. Can anybody confirm that the sound is clear? Okay, thank you. So, first of all, thanks Institution of Engineers and all the people behind the Institution of Engineers to invite me again for the lecture on SPD. Actually, this hall is very well known to me. I think probably I'm speaking maybe 6th or 7th time in this hall. And I have in my table, in my office, the same blue color, the memento. I have now I have about 5 or 6. Thank you very much. I think it's a good idea to write the year so that we can remember. So now today we are going to talk about SPD, surge protection device. Basically, it is about protecting electrical and electronic equipment from failures. Now, first of all, about these standards. The standard which we are talking is 61643, this one, IEC SC 37A. The IEC standard is made by TC 37, which has got a sectional committee SC 37A, which makes the standard IEC 61643. I think about 40 plus countries are members in this particular standardization group, and I am a partner, or I am a part in the working group 03 and working group 05. Working group 03 explains or make the part 21 of the standard, which is explaining about, part 12 of the standard, which is explaining the application guide or application of selection and erection of SPDs. Working group 05 makes the standard on testing and performance requirements of SPDs. So this is the background. Now, these are the standards with respect to surge protection, or I don't know how to minimize. Yeah. Yes, I'm working on that. It is not coming in.
It's not coming in.
Yeah.
Next time.
Let me keep it in the corner. Okay. Now, the standards are IEC 61643. I'm sure you are able to see the pointer as well. 61643. There are several substandards. For example, part 11 talks about low voltage power system, testing requirements, testing performance requirements of SPD. 61643 part 12 talks about selection and application. Then similarly, 21 and 22 talks about the communication and data SPDs. 31 and 32 talks about solar PV. So there are several standards with respect to SPDs. Now, SPD also has to be selected and erected in an installation based on IEC 60364-553. This is the basic electrical safety standard which we spoke last time in the hotel a few months back. 60364 is the global standard. I'm sure all of you are aware of BS 7671. So 60364 is the base standard for BS 7671. So we should also refer these are with respect to the standards. Now, with respect to safety, the fundamental concept which is made is equipotential bonding. That means during the transient condition, during a short time, once when there is a problem in the installation, or once when there is a lightning or a transient situation, potential differences should not exist between conductive parts. That is the basic idea. You have to make every metal part at the same potential as close as possible. This is the concept which is followed for electrical safety, as well as for lightning protection system, as well as for SPDs. Why I am making this statement is, a lot of places if we see, people buy good quality SPD, but the earthing wire of the SPD is routed to a separate earth electrode, and they think that lightning current will go through the SPD, it will go to the earth electrode. It is not like that. You should connect the SPD within the bus bars of the distribution board, for example, and you have to use the shortest wire. So I will explain it later. Now, I have a lot of sections, but I will skip some of most of this because the whole presentation is for 2 days, which is too much. Maybe we can have several sessions later. But what you should understand is, today's subject is SPD, surge protection device. Whereas, if you wanted to protect electronic and electrical and electronic installation, especially electronics in your building, we have to make SPM. SPM stands for surge protective measure. SPM consists of protecting the electronics from conducted and radiated effect of lightning. Radiated effect can come through air. It can pass through air and destroy electronics. It can create surges into the wiring system, and those surges can kill the electronics. So for protecting entire electrical and electronic system, you need SPM. SPD is only a device which is going to create equipotential bonding during a transient condition. This difference you should always understand, because sometimes people expect SPD to protect the entire electronics, but sometimes it don't. So SPD protect against any kind of conducted surges. Conducted surges means through a metallic conductor, some transient over voltage is passing. The SPD will create a bonding, or it will create an equipotential bonding, so that the conducted surges are not destroying the equipment. That is the important point. So you should keep this in mind. Because, for example, SPM, as I told, SPM, surge protective measure, which consists of shielding, bonding, cable routing, and so on. Those subjects are actually, it becomes very critical in a highly electronic environment, for example, defense, or for example, some kind of research institutes. And nowadays we use electronics everywhere. So it becomes important everywhere. Now, first of all, about the definitions which is explained in the standards. Sometimes country to country, there are some differences. Please excuse me. I am just trying to explain what is there in the standard. So 230 volt, I am just showing an appliance and a line, neutral, and a PE conductor. 230 is the nominal voltage. So under nominal voltage, all your equipment are safe. Nothing happens. Maximum expected continuous voltage. That means out of this 230, how much voltage, for example, in a low voltage distribution system of a utility company. So the transformer tapping voltage will be put a little bit higher, so that there is a voltage drop, and the last consumer also should get a voltage within certain limit. So if you look at the consumer premise of the first consumer, probably the voltage is a little bit higher than 230 volt. So that particular limit is what we call as maximum continuous operating voltage. It is plus 10%. So you can put up to 10%. But of course, you see, the voltage drop calculations and those things are also there. So under maximum continuous operating voltage, your equipment is supposed to be safe. Then any voltage more than maximum continuous operating voltage, let's say 255, 260, 270, such voltages can also come into the line, and it can exist for a longer time. So here, in case, if the voltage is more than, let's say 260, 270 volt, some of the equipment may fail. It depends on the kind of equipment which you are using. Now, for example, the duration, let's say 270 volt for 15 minutes, maybe this is there can be a chance of failure. Similarly, a voltage which is even more than 300, 320. So here the failure will be much faster, because the voltage is even more. The withstanding time will be very small, because through the conductors more current flows, and it creates. Similarly, if we look at the voltage, the line to neutral voltage, if it is, let's say 1000 volt or 1200 volt, the equipment may withstand, let's say, for example, 10 seconds. These timings I am just putting for example. 10 seconds it is able to withstand. So under this condition, one of the tests which is made mandatory in IC is line to earth. Every equipment line to earth must be able to withstand 1200 plus UN, means 230 volt, 1430 volt, or 30 volt for line to P, between line to P up to 5 seconds. This is a mandatory test required for every equipment. That means between line to earth or neutral to earth. That means the basic insulation is tested 1200 volt for 5 seconds. Very important. So under these conditions, the equipment, under these the conditions which is mentioned here in the list, the equipment may be able to withstand depending upon its construction, or if the equipment cannot withstand, the installer, he has to disconnect the supply. Something should trip. There shall be an over voltage relay and the relay should trip. Similar way, look at if the voltage is not 1 kV, 2 kV, if it is 5 kV or even very high voltage. So insulation failure will happen very quickly, maybe 100 milliseconds. Similarly, even a higher voltage, the failure will be much faster. So under these conditions, of course, two solutions, equipment may withstand, which is impossible, you know very well. Or what we should do is limit this transient over voltage. Let's say 30 kV is the voltage which is coming to the equipment because of lightning activity. You cannot switch off your equipment because switching off will take few milliseconds. Switching off will take time and you have to sense it and switch it. Before that, the voltage comes and it destroys the equipment and goes back. So what you should do? You should put some device and you should ensure that the limit of the voltage, this 30,000 volt is reduced to certain limit, which is equal to the withstanding level, insulation withstanding level of this particular equipment. So impulse withstanding capability. So first point of the surge protection is what do we mean by insulation withstanding level of an equipment? So insulation coordination we should look. And finally, every equipment which is a device which is in compliance to the standard, every equipment after manufacturing or after design, it's a type test. The device has to be tested with an impulse voltage. Impulse voltage means a high voltage for a short duration. The waveform is 1.2 to 50 microseconds. So every equipment is supposed to be tested with this kind of an impulse voltage. And for low voltage, the equipment manufacturer is supposed to categorize that particular equipment. There are 4 categories. Category over voltage, category 1, 2, 3, 4. Category 1 means an electrical device which can withstand only 1.5 kV. 2 means 2.5 kV, 3 means 4 kV, and 4 means 6 kV. So now to select a surge protective device, the first parameter you should understand is this voltage impulse withstanding capacity of your electrical installation. Because imagine your withstanding capacity is 1.5 kV and you are putting an SPD which is clamping at 4 kV. So there is no use because SPD, the electrical device will fail. So first parameter to be understand is you should look at the manufacturer's catalog, especially for example switch gears and all, you can find this parameter. Installation category or impulse voltage withstanding category. So that is the first parameter to be looked into. Then you should also understand that, one moment. You should also look at where these installation, where these devices are installed in your building. For example, according to the recommendation of the standard, every electrical apparatus which is coming at the main distribution board must be of category 4, fixed part of the installation category 3, connected portable appliances category 2, and the category 1 device. Actually, we are not supposed to connect directly to the supply coming from the distribution transformer, from the supplier's side, from the DISCOM. I don't know what you call. In India, we call DISCOM. Here, the name is DISCOM. Distribution company is called as DISCOM or something else. Okay, utility. Okay, the power supply which is coming from the utility. Actually, the class 1 device we are not supposed to connect directly to the transformer, which is the utility transformer. We are not supposed, because it will fail. Because in case of any fault on the HT side of the transformer, LT side of the installation can experience a temporary overvoltage and these devices will not withstand. That is the reason. Now, so the second parameter is you should also look what kind of devices are there and where these are installed. So you should have some idea. several categories are there. Simply you go to the manufacturer's catalog and you can have a look on this particular thing. Similarly, for example, industrial application, let's say a control panel, which is having operating voltage, let's say some portion operating at 230, 400 volt, some portion operating at 24 volt, some portion operating with a different communication device. So under these conditions, there are some basic insulations required between different devices. So the panel builder should have made those arrangements properly. Say, for example, between an extra low voltage, let's say you can see here, main circuit and the SELV PLV. SELV PLV is, let's say, for example, 24 volt device. Between 230 volt device and an SELV PLV equipment within inside a control panel, we are supposed to have double insulation. Most of the time, these practices are not very well followed, or it's very rarely followed, which is also one of the reasons for failure of sensitive electronics. So I hope the picture is clear. What I have put is this green color is insulation. Between 230 volt equipment and 24 volt equipment, there has to be an insulation. Insulation can be several methods. For example, you can physically keep it away. But what happens is sometimes you have a terminal, one terminal is 230 and the next terminal is 24 volt. So then we lose. So we have to be careful. So all these subjects are actually interrelated. All these ones when we talk about SPD. For example, we have to, the equipment which has to be protected also should be made according to the conditions stipulated in the standard. Now, what is an SPD? SPD is a simple device. It contains some kind of non-linear equipment device inside. Say, for example, an MOV. You know very well that in an MOV, under normal condition, the resistance is very high. Once when the voltage, it's a voltage dependent device. Once when the voltage is high, it changes its characteristics and the resistivity goes down to a very low level. So that means if this device is connected between line and neutral, that means parallel to the line, during normal condition, 230 volt or 240, 250 up to 300 volt, nothing happens. The device is offering a very high insulation or very high resistance. But once when the voltage is crossing, say for example, 1.5 kV or 2.5 kV, then suddenly the resistance offered by the device is very small. As a result, both line and neutral is almost connected. I have a picture, I will show it later. So MOV based devices are called as voltage clamping type device. Similarly, there is one more device which is a spar gap or a GD tube, and these are called as voltage switching type device. Say for example, as you can see here, this green one, for example, once when the potential difference between the terminals reaches its spark over voltage, suddenly the device will act like a switch and the line and neutral is connected. So this is very important. The voltage clamping device, voltage switching device, understanding its characteristics is also sometimes important while selecting an SPD. Now, the components, the previous one was the component, MOV and the GD tube. So now, once when we call this component as an SPD, then it has to be inside a casing. It has to have its own protective measures. For example, always an MOV fails in short circuit condition because MOV is meant for it. MOV, because if it fails in open condition, you cannot detect. So in order to detect its failure, MOV is always die in or end its life in short circuit condition. Once when we wanted to call this MOV as an SPD, then that particular SPD, inside the casing, there shall be some, I just take the sample please. So now, I don't know whether they can see, probably yes. You can see that. So, okay. So this is an SPD. So inside this casing, it is not only an MOV. it contains a thermal isolator. Means it's a pressure silver soldering, pressurized silver soldering. Once when the temperature is more than 80 degrees, it opens. Why that particular safety measure? Because MOVs will generate heat and it will die. The temperature more than 80 degree means this is going to die. So before it creates a short circuit, the thermal isolator will disconnect the MOV. Similarly, it sometimes will have its own fuse inside. Sometimes nowadays HRC fuse inside, which is the best models. HRC fuse means there is an internal fuse. And that, SPD is an MOV which is having all these safety measures inbuilt. Similarly, there can be several type of SPDs, only MOV, only GD tube, sometimes a series parallel combination of GD tube, MOVs and so on. It depends on the design of that particular SPD. One of the SPD which was used long back was spar gap. Spar gap SPDs. Spar gap, as the name tells, spark gap. So there is a gap, and once when the potential crosses the limit, it creates an arcing. Those SPDs, during most of the time these SPDs are not available in the market from good manufacturers, but still you will get it if you go for a cheaper SPD. Cheaper in the sense, sometimes there is a tendency in India, I don't know about Sri Lanka, in India people get something from China and put a label and sell. So spar gaps have this kind of a problem. Spark over will come out. So these are called as blowout type SPD. Blowout. Blow means whatever the arc created, it blows out. So you have to mount it with special care. And one more device available is called as, for example, encapsulated device. Once when we started selling the device during 1997, so almost all spar gap type SPDs were blowout type. Blowout type means you can be sure that if the SPD operated, then if you look at its backside, maybe half meter, then the entire place is black because of the arcing. It is designed for that. After that, a new technology came, which is called as encapsulated. Encapsulated means completely sealed SPD. One of the first technology which came is carbon spar gap. Carbon means there is a gap, but the material which is used, previous it was tungsten, then it was changed, one of the manufacturers changed it to carbon, graphite plate. It's a sealed SPD. The problem of this SPD is this graphite will have fine powder. And if you shake the SPD very well, and if you make like this, and then if you test the SPD, it will show one characteristics. Voltage protection level maybe 1.2 kV. Then you make it again 2-3 times and test it, it shows another character. The voltage protection level will change. So as a joke, I used to tell that these SPDs, before, don't shake it like, in the medical store, once when we buy some medicine, shake well before use. So like this, don't shake this device while using, you will be in trouble. So now, how does the SPD works? You just look at the picture. We call it as 3+1 connection. 3+1 connection means between RYB and neutral, there are 3 SPDs, and between neutral and earth, there is 1 SPD. So technically, we call this as 3+1. 3 between line to neutral, 1 between neutral and earth. Now imagine, there is a lightning strike, and as a result of the lightning strike, the ground potential is increasing. Lightning, ground potential, these are big subjects. Probably we will talk in another time. So because of the lightning, the ground potential is increasing. I am just putting this green wire to red because suddenly, due to lightning, the potential of that particular wire is going very high. And how does the SPD operates? In normal condition, SPD, the internal resistance is very high. The resistance is very high. But once when the voltage between the terminals is more, suddenly it makes, imagine it's making a short circuit. Just for the time being, it's making a short circuit. Then what happens? Now the potential of the earth wire is very high. The SPD number 4 operate and it connect the earth and the neutral. suddenly your neutral and earth are connected together very fast. Maybe in few nanoseconds this happens, or maybe in 2500 nanoseconds this happens. So what will practically happen is between neutral and earth, you have connected it. The earth potential is now available in the neutral. Between earth and neutral, there is no potential difference, but the neutral potential is very high with respect to a faraway place. Then what happened is the other three SPDs also operate, and then suddenly all the lines plus neutral plus earth, everything is connected together. As a result, what happens is there is no potential difference. And if you look at an equipment which is connected downstream the SPD, there are certain conditions apply. Generally, if you have a very good wiring means from the distribution board up to your equipment, if the length of the line, neutral and the earth wire is similar, so sometimes the length is not similar. We really don't know. It depends on the quality of the workmanship or the quality of the electrician. In a good electrical installation, from the location of SPD downstream, there is no potential difference. As a result, your equipment will not experience a voltage for a short time. Suddenly, the potential between line and neutral, let's say, for example, you have a TV. Between line and neutral, voltage is zero. For a very short time, for few milliseconds or microseconds, your TV itself will not sense that. So, you will not feel, or electrical equipment will not feel this short circuit. What will happen is, the potential is very small between the line and neutral or line and earth. As a result, your equipment is safe. Now, the SPD, which is in a shorted condition, also should come back to its original situation. So, after the passage of the surge, transient current, it has to return back to its original situation. If it didn't return back, what will happen? Can anybody answer? If the SPD has worked, but it has created a kind of a low resistive path between line and neutral, but it didn't return back to its original position. That means you have a short circuit. So the entire installation, you have to have a backup protection. Otherwise, the entire installation can catch fire. SPD is a very critical subject. Even in the IEC level, still discussions, a lot of discussions and research is going on to develop or to increase the safety of SPD. The challenge is always the SPD fails, but the backup protection don't work. There is an MCB or there is a HRC fuse. Before the HRC fuse fails, or before the HRC fuse blows, SPD will burn. Lot of cases we can say. So SPD, this is what it does. It creates an equipotential bonding. Immediately after the transient, it returns back to the original position. Now, with a picture, I'll just explain you how this is applicable to a house in case of a direct lightning strike in the building. You have a building. Now things are very safe because, that is why I shown it green. You have the power supply coming from the utility company, transformer, maybe it is half kilometer away. The operating voltage line to peak, you can see here. Now imagine there is a lightning strike on the building. So you can see the current goes wherever the current flowing, for example, through the down conductor, potential of that particular area will be very high in comparison to, the other area is at a different potential. Just for an explanation, I have put there is only one down conductor, the current is going through the down conductor, that area is red, means that area there is a lot of electromagnetics or potential, high potentials are existing. Now, first of all, you have to make an equipotential bonding in your building in such a way that the entire building is at the same potential. All the metallic parts of your building is at the same potential. So very good equipotential bonding is made. As a result, the whole building is red. Within the building, there is no damage because everywhere is zero potential. Now, where do you expect the potential difference? The potential differences can be expected between the earth, means that particular building, and all metallic services connected to the building. Say, for example, the power line. The power line, line and neutral, is at a totally a different potential. The reference of line and neutral is to the neutral earthing of the transformer. So it is at a different potential with respect to the building. Now what we should do? Now this is between the line and between the lines and the earth, you will experience the transient over voltage, which is nothing but the potential equal to the the 0 and the 1. Now what we should do? Now I have made this place where I am moving the cursor. I will go back. You see, I have made a red color line. So the idea of this red color line is, I have made with an SPD, I have made an equipotential bonding at the service entrance, means at the meter board. So as a result, the entire building as well as the services incoming are at the same potential. So there is no failure. People always, then what will happen? The lightning current will take a path. It will go through the power line. To some extent, it will pass through the power line. It may destroy your neighbor's building. People always ask, if I put a SPD, lightning current is diverted. As a result, the neighbor's building will burn. Before asking this question, you should think, what will happen if there is no SPD in your building? If there is no SPD in your building, here at the service entrance, spark over will happen, failure will happen, and the current will pass through the same route. Anyway, the current is going to flow through the power line. The question is, without an SPD, it will destroy your distribution board and flow. With an SPD, your distribution board is protected and it will flow. That is the only difference. So you don't need to be worried thinking that SPD is diverting the current to the line. As a result, my neighbors will be in trouble. Not like that. So otherwise also neighbor will be in trouble. And normally, it's a common mode phenomena because the potential in case of a direct lightning strike on the building, a common mode phenomena means the potential of all the four wires like line and three phase and neutral is going up with respect to earth. So let me skip. What is recommended or what is the best practice is to have an SPD at the service entrance, something like this. This is not a 3+1 connection. It's a, we call as 4+0. This 0 has got no value. There are 4 SPDs between each of the current carrying conductor to earth, as you can see here. So 4+0. So the service entrance SPD, the best option is to go for a 4+0 SPD, something like this. But of course, challenges are there. Now, with respect to the current, we should say, for example, you have selected an SPD. Let's say, one moment, please. Now I am showing you 2 SPDs. One is a big one and the next one is a small one. The big one can handle very strong current. It's very strong, very big SPD. The small one, as you know, it's a small one. It cannot handle so much current. The current handling capacity is limited. How do you select it? One of the method is, one principle which is explained in the standard is 50-50. Out of the total lightning current, 50% lightning current gets dissipated into a building or dissipated into the earth of the building, and approximately 50% gets diverted to the connected services. Connected services in the sense, if you have connected services are probably metal water pipe, metal gas pipe, then your power supply and so on. Most of the time, metal water pipe, metal gas pipe, these are not existing. We have only the power line which is coming from the utility or from the distribution company. So approximately 50% of the total lightning current gets diverted to the line. Now, imagine your total lightning current is 200 kiloampere. You have a very big building, very good building, and maybe the entire building you have made the highest level of protection, 200 kiloampere. Then the rating of the SPD is 100 kiloampere because 50% of the current is getting diverted, then you need this kind of a big SPD. But imagine you didn't go for the highest lightning protection. You have gone for level 3 protection, 100 kiloampere. So 100 kiloampere protection, 50% of 100 kiloampere is only 50 kiloampere. You don't need to go for this big SPD. You can go for the small one. So this is the way you should select the rating of the SPD, because as I said, any matured product, after some time, the cost goes down. For example, RCCBs, you know very well. During the initial days, RCCBs were very expensive. But after some time, the prices went down because the market matured. Everybody knows, people knows how to make it and test it. As a result, the prices went down. Whereas, I don't know whether you are aware or not, RCCBs are also 4 types, type AC, type A, type F, type B. Mostly we use type AC RCCB, am I correct? But for LED lights, we are supposed to use type A RCCB, and for solar rooftop installation, we are supposed to use type B RCCB for the AC line. A type B RCCB will be, in India, I think it's about 20,000-30,000 rupees, maybe here a lakh rupees. So very expensive. In comparison to a type AC RCCB, type B RCCB will be very expensive, because those RCCBs, still it's a new development. Still productions are, still research is going on. Similarly, at the moment, the SPDs are a very expensive, item in the electrical installation. But in the market, you get lot of inexpensive products. But the problem of these products are, of course, a lot of challenges are there, especially safety challenges. One more time. Now, this is the technique, which is one of the techniques. Several techniques are there. One of the technique which is used to find out the current carrying capacity, surge current carrying or impulse current carrying capacity of the SPD, 50-50 formula. Now, once when we talk about SPD, there are 2 wave shapes, current wave shapes, which we are supposed to discuss. The first one is called as 10/350 microseconds, which is the energy equivalent of a partial lightning current, direct or partial lightning current. Partial lightning current means the whole lightning current, the current created because of a direct lightning strike, a part of it is going to flow through the SPD. Or the lightning current, the energy equivalent of lightning current is termed as 10/350 microseconds, means it's a current flow. The current goes from 0 to peak in 10 microseconds. It goes to top in 10 microseconds and comes to half value in 350 microseconds, as you can see here. The next wave shape is called as 8/20 microseconds, which is the equivalent energy of a switching surge. Because, once when we operate some electrical apparatus, transient over voltages are created, the energy is very less. Those energies are termed as 8/20 microseconds. Termed in the sense, what is the purpose of this terming? Because everybody should manufacture a product according to certain standard. So these are the standardized current wave shapes. 10/350 and 8/20. 10/350 is direct lightning, 8/20 is switching surge or a capacitive or inductively coupled surge. Now, where to use these SPDs and what are its name? For example, earlier classification, class B, people used to ask, I want a class B SPD, class C SPD. These were the names which was included in the German standard a few decades back, because Germans were the first one who came out with a proper standard. So those were used internationally. As a result, people start calling these devices as class B, for example. Now the name is type 1. Type 1 is an SPD which is tested for 10/350 microseconds. You can see here, test current 10/350 microseconds. Similarly, type 2 SPD, which was called as type C, no more class C, sorry, not type C, class C. No more class C. Class C is not used nowadays. Type 2 is used. It is an SPD tested with an impulse current of 8/20 microseconds. There are 2 type of tests included. One is nominal discharge current, means 20 times each SPD should handle 20 times its nominal discharge current. Imax means maximum discharge current, one time it has to withstand. These are the impulse wave shapes. Now LP is a lightning protection zone, 0 to 1, 1 to 2, 2 to 3. So basically these are the classifications. Now in the market, if we look, most of the time, the SPDs are called as type 1 plus 2, type 2 plus 3. The simple understanding is this is an SPD which is tested for both the parameters. The requirements of type 1 as well as the requirements of type 2 are carried out in the device. Now you should look at how much type 1 current it can withstand, how much type 2 current it can withstand. Those parameters only we should look at. Type 1 plus 2 or type B plus C or class B plus C, that is, I would say it's a meaningless word. So it's an SPD which is tested for both the parameters. Instead of looking at type 1 plus 2, you should look at how much current it is able to handle, because that is the most important point. Say for example, this particular SPD which I have just now shown you, the first one, the big one, basically it's a type 1 SPD, 100 kiloampere, 10 by 350 microseconds. But if you look at the specification, it's written as type 1 plus 2 because type 2 parameters are also tested there. And there is another SPD, type 1 SPD, 50 kiloampere, type 2, the third picture, type 2 is at 12 kiloampere, 10 by 350, and all these SPDs can be called as type 1 plus 2. But why I show this table on the right side is here type 1, 100K, 50K, 12K is type 1 plus 2 is not, it's not a meaningful word, whereas these current ratings are meaningful. So you should look at the current ratings. What kind of SPDs are there? SPD categorization. There are different kind of SPDs. As I said, the SPD technology is still an emerging technology. New and new technologies, new and new research is going on, and the companies are coming out with the new products, patented designs, and so on. Now, for example, the one which you are seeing here, this one, this is an SPD. The one which I am showing you, this is an SPD, but it do not looks like a conventional SPD. This is a bus bar mounted SPD. The advantage of the SPD I will explain you later. Or we can say that this SPD between line and neutral, you can connect it on the bus bar, directly on the bus bar, and the energy handling capacity is very high. This is one SPD, not four, one SPD. And if maybe once when you get time, you can look at the weight of it. This is the medium size. There is one more which is even bigger. Then another SPD. It's a patented phase. As I said, every manufacturer is coming out with the new patented designs because the technology is still emerging. These SPDs which I am showing here, they have a fuse, HRC fuse inbuilt. It is having a big advantage. I will explain you later. Then this is another device, and maybe these are some of the technologies which is used. All the SPDs which we are showing are VDE as well as UL listed. Now, the first one. It's a very simple construction. This round color SPD is a very simple construction. It consists of a very big industrial beauty metal oxide varistor. That varistor is a patented one. It's a high quality metal oxide varistor, for example, which is mounted on this black portion, and up and down of this MOV is pressed inside this particular aluminum can with I think something about 1,500 pounds of pressure. As I said, the SPDs are always failing because of heat. Once when the current flows through the SPD, it heats up. And because of the heat, after some time, it fails. So you will you can increase the quality of SPD if you remove the heat as quick as possible. So that is what is done here. Very simple. This aluminum, pressed aluminum, is acting like a heat sink. So even if the SPD heats up, it won't fail much faster like the other one. For example, this SPD is tested for 10 kiloampere, 1000 strikes. 10 kiloampere, 1000 strikes means, you can imagine how many lightning it can handle. Whereas the other one, DIN rail mounted, it can handle only, for example, 20 strikes. The 21st, it may fail. Now, the advantage of this particular SPD is, before going to the advantage, I will show you another, the background of this discussion. Then I will come back to this particular slide. I am sure you are aware of the problems with respect to the lightning current flow in a conductor. So once when the lightning current flows through any conductor, depending upon, we say L di by dt, depending upon its length and the rate of change of current, a large voltage is, accumulated, or there is a large voltage drop, potential drop on this particular conductor, based on which separation distances and so many calculations are made in the recommendations are made on the standard. What we should understand is, lightning, there are 2-3 types: positive strike, negative strike, subsequent strike, long duration strike. We will discuss it later. Now, in a subsequent strike, for example, the rate of change of current is very high. The di by dt is very high. Let's say, for example, 200 kilo kV per, 200 kiloampere per microsecond, very high, di by dt. What happened is, once when this current flows through a wire, huge potential is getting generated or getting created in that wire. Now imagine, you have an SPD like this, A and B, let's say line and neutral. Between line and neutral, you have a wire, because the SPD is mounted on a DIN rail, not this one. For example, the SPD is mounted on a DIN rail. You take a wire from the phase terminal and connect it to the SPD. Then from the SPD, the earth wire again connected. So something like this. And sometime in between the line and the SPD, you need a HRC fuse as well. HRC fuse or disconnecting device, because once when the SPD fails, this device should isolate. As I said, all SPDs may be creating short circuit. So you need an additional fuse to disconnect the SPD from the line. So imagine this is the way it is connected. Now what happens is, these connecting wires will offer certain impedance. It's not a short wire. Sometimes the wires are maybe 1 meter, 2 meters, sometimes 250 centimeters, the maximum recommended. Now, the ultimate purpose of putting the SPD is, the voltage between the transient over voltage between point A and B has to be limited to a very small level, because your equipment can withstand only, for example, your equipment can withstand only 2.5 kV. Our aim is, between the point A and B, potential should be lesser than 2.5 kV. Let's say 20% lesser. So don't allow more than 2 kV. That is the purpose. But because of the line L1 and L2, more voltage drops on these wires. As a result, the effectiveness of SPD is gone. So this is the condition we are supposed to look always. I would say, when you install an SPD, the most important subject to be considered is the line length. The maximum allowed line length is 250 millimeters. 250 millimeters. That means such a small wire, such a small wire, you are supposed to connect the SPD. Is it possible in an existing distribution board? Most often no. Then what happens? You use a longer wire. Once when you use a longer wire, its effectiveness is gone. It won't really protect. So this is you have to be careful. Now, most of the time you see SPDs are connected in this fashion. This in the first case which I am here, this is in an airport. The connecting wire length recommended is 250 mm, and the actual wire which is used is about 5 meters. So this, I would say this SPD is a showpiece. People will look at the SPD, aha, I am protected until the next lightning. Otherwise, it won't do any job. So this subject is very, very important. I have some calculation. Let me skip those calculations. Now, what is important in this particular case is the bus bar mounted SPD, you are directly mounting on the bus bar. As a result, the line length is nil, 0. So then if you compare the SPDs here, for example, the red color line at the bottom is the protection level, voltage protection level of a bus bar mounted SPD. Say, for example, this line, which I am moving the cursor here, this is the ultimate voltage produced during a transient condition between point A and B. You can see that maybe about 1.5 or 1.2 kV. Whereas this blue color is a DIN rail mounted SPD with a 250 mm wire length, not big wire, 250 mm wire length. For example, in a 10 kiloampere surge current flow, the SPD with wire has clamped the voltage to something about 4 kV, whereas the bus bar mounted is still 1.2. 20 kiloampere surge, the actual voltage going into your equipment is about 8 kV, whereas the bus bar mounted is still 1.2 kV. So basically, once when you connect the SPD, you have to use the shortest wire. If your equipment is more and more sensitive, then DIN rail mounted SPD sometimes may not be efficient, and you have to go for this kind of an SPD. Now, these SPD, the advantage, as I said, there are 3 models, strikes or 30, 40, 60. And these SPDs, we can say type 1+2 because both the 8x20 and 10x350, it is tested, for example, 7.5, 60 kiloampere, 12.5 and 140 kiloampere, 25 and 200 kiloampere. Similarly, multiple current impulses, all these SPDs are tested for 2000 strikes of 10 kiloampere. 2000 strikes of 10 kiloampere. You see, we also should understand one important subject. Lightning sometimes is a continuous phenomenon. One after the other, it will fail, it will fall. Now, this DIN rail mounted SPD, if you look at the test parameter of this SPD, an impulse current is given. So there is a lightning current flow through the SPD, then it heats up. Then it has to be cooled down to room temperature, then the next impulse is given. Again, cool down to 20 times 20 strikes, for example. Every time the current flows, it's hot, it's brought down to room temperature, and the next impulse is given. We should understand that lightning, after one flow, lightning will not wait for the SPD to cool down. You got it? Lightning may be continuously coming. So that means there is a risk. Even if you have the best SPD, there is a risk that even if you have the DIN rail mounted SPD, the best one, but there is a risk that it may fail because if the lightning is continuous. So in such critical cases, the best way is if your installation is so critical, then you can go for this kind of a bus bar mounted SPD because these are tested for multiple strikes. So similarly, this is also tested for long duration strike. I would say this is the only SPD which is tested for long duration strike because this is a non-standard test. The standard didn't recommend so far this kind of a test. Now, some of the installation examples. So the wire length and the selection of SPD is very, very important. So these are some of the SPDs which we are discussing. Now, how to use and where to use the SPD? As I said, the whole subject is called as SPM, Surge Protective Measure, which consists of several measures. protecting your electrical and electronic equipment from conducted and radiated surges. So conducted in the sense through a metallic conductor, a surge is traveling. Radiated means through air it is traveling. Now, the building to be protected is divided into various zones, lightning protection zone. This is theory. Lightning protection zone, for example, an area within the building can be called as zone 1. An area further inside the building can be termed as zone 2. Similarly, up to zone N, you can make. The important point is, within a protected zone, the conducted and radiated energy has to be limited. Radiated energy, to limit radiated energy, we have to have a shielding. Shielding in the sense the metal, if you are going for, let's say, for a defense installation, very sensitive electronics, or communication installation, very sensitive. For those kind of application, you have to make like a Faraday cage. So you have to have a Faraday cage and your electronics shall be inside Faraday cage. Then only your devices are protected against a radiated effect. Now, one of the principles which is used in the IEC standards, not only surge protection, all the EMI/EMC radiated protection is zoning of the building. Building is divided into various zones with respect to lightning protection zone 1, 2, 3. 1 means the conducted surges limited less than 4 kilovolt, 4 kV. Zone 2 means less than 2.5 kV. You know, those classifications are there. I don't want to go into it because sometimes it confuses. So what do we do? At the main distribution board, technically, if you read a standard, it says between zone 0 to zone 1. Very simple. At the main distribution board, you have to put an SPD. And that particular SPD is called as type 1 SPD. See here, type 1 SPD. The color, from the color you can identify it. The second one, the black color, is at the sub-distribution board. Technically, it's called as zone 1 to 2. Here you have to put a type 2 SPD, and that type 2 SPD should limit the voltage to less than 2.5 kV. The first one should limit the voltage less than 4 kV, because in this location, the LPZ1, the electrical equipment, fixed part of the installation, those equipment can withstand only 4 kV. I told you at the beginning, voltage impulse withstanding testing. The equipment can withstand only 4 kV. So the device should limit the voltage to less than 4 kV. Less than 2.5 kV and less than 1.5 kV. That means that the main distribution board on SPD, sub-distribution board another, probably near to the equipment, you need one more. But these all depends on the type of building, size of the building, size of electrical installation, the way you routed the cable. It is not like simply, you cannot apply this principle for a small building, the same principle for a large building. That is not possible. We have to really analyze the situation and do it. So, until then, I would say this is actually an expert's job. You need the support of an expert to select this particular thing. From the standard point of view, this is also categorized. For example, you have the transformer at the main distribution board. You can see here 3-phase and the neutral. You have the SPD. This is a type 1 and or type 2. You can use sometime type 1 or you can also use type 2. At the main distribution board, type 2 is also allowed. Where, for example, you don't have any lightning activity nearby. There is no lightning strike in your building, or you don't have any lightning protection for your building. In that case, you don't need to put a type 1 SPD, or your incoming power cables are all underground cable. So the chance of lightning hitting the line and taking the energy through the line is less. Under that condition, you don't need to go for a type 1 SPD, you can go for a type 2 SPD. All these conditions are included in the standard. Similarly, in the sub-distribution board, you can go for type 2 or type 3 SPD. Near to the equipment, again, type 2 or type 3 SPD. This all, as I said, it depends on the type of building, size of building, and the type of electrical installation and so on. Now, what kind of protection you need? You need protection in a typical building. You need protection from source S1, which is a direct lightning strike on the building. That means your building should have a external lightning protection system. Here, once when we talk about external lightning protection system, please note that most of the buildings in Sri Lanka have the single down conductor lightning rod. That means one rod at the top and there is only one down conductor, which is very dangerous. The standard never recommended to go for one down conductor. You need to have multiple down conductors. With one down conductor, if we calculate, you have to take the down conductor maybe 2 meters away from the building. Practically, it won't work. So in modern buildings, the best way is to use the steel of the structure as down conductor. Because in our construction, we use steel. There are columns, there are slabs. Make use of that steel and ensure that the entire building is able to handle the lightning current. So, which is the best way? So, the first one is S1, direct lightning strike on the building. Second is S2, a direct lightning strike onto the service. For example, an overhead line. If the line is underground, this thread is gone. There is no thread. So, this is applicable for an overhead line. The S3 is a direct lightning strike near to the building. S4 is a lightning strike near to the service. These are the 4 probable threats of lightning. Now, how it operates, I already explained to you. Let me skip this particular thing, but very important for you. Now, look at the picture. At the main distribution board, you have an SPD. And the SPD has made an equipotential bonding. Now, if the distance from this place, from the location where SPD is installed and to the internal system, if the line length, for example, all the 5 wires, the length is almost equal, then the equipment will not experience a surge. But there are new principles applied in the upcoming standards. You can see that there is a reflection phenomenon. Reflection phenomena means there is a surge arrestor and its effect is probably maybe 20 meters. After 20 meters, there can be an effect. So that means, multiple surges, multiple SPDs are required. So, but in a simple understanding, if the wires are made in this way and if these wires are shielded, let's say it is going through a metallic conduit. Under that condition, your equipment is safe. What happens? The current goes back to the source. As I said, don't worry, it will not destroy your neighbor's building, because if you don't have SPD, the lightning will destroy your distribution board and go to your neighbor's building. So, I will go through some of the important part, because I have so many. Totally there are about 370 slides. This is for 2 days. I will go through some important part. Basically, I wanted to talk more about the installation practice, because buying an SPD anybody can do, but installing it properly is equally important, or I would say more important. So once when you install an SPD, or let us say, for example, one typical problem which is facing in India, for example, I am just showing you a 3-phase and maybe a single-phase equipment connected to a 3-phase. Now, very simple explanation. Line to line, you have 400 volt. Line to neutral, you have 230 volt. And imagine you have 3 SPDs between line to neutral. 230 volt, the SPDs are very good. Now, for example, if the neutral disconnected, neutral isolation, is it common in Sri Lanka? Rarely it happens, right? The neutral goes, there is no neutral. As a result, what happens between the wiring neutral inside the building and the phase, you will have a high potential. So, in this case, just imagine the neutral isolated. Under that condition, what will happen? So, one of the SPD, because you have a single phase equipment in on condition, I have tried to make it as simple as possible. Sometimes layman also, it has to go up to non-engineer. That is where I made it. So you have a single phase equipment which is in on condition. So the potential between those 2 lines are line and neutral is 0. Potential of neutral to the other 2 lines are now 400 volt. And how much time will it take to rectify this defect, which is the neutral isolation? How much time it take? Nobody knows. Am I correct? It may take half an hour or 2 days. It depends on the location. Nobody knows. In India, it's a big problem. In several cases, neutral isolation, and the first item to burn is the inverter. Every house have got an inverter. Lot of house, not every house, probably 50% of houses have got inverter or UPS. The first item to burn is this inverter. Then the rest, refrigerator gone, one by one things will go. Now what happens is, in this condition, what happens to SPD is, two SPDs are stressed with a 440 volt continuously for a longer time. As I said, SPD is a voltage operated device. There will be a leakage current, higher voltage, SPD rated for 230 volt, and the applied voltage is 400 volt. Higher current flows through this SPD, it heats up and it can catch fire. And lot of fire accidents happen. For example, even in Sri Lanka. I remember maybe 2003 or 2004, when I first time, when I came to Sri Lanka, we went to a church. I think I don't know where it is. It was far away from Colombo. A father was running a church and a school, and there the SPD failed. Then finally the conclusion was it was a temporary over voltage, neutral isolation, and the SPD burned. Unfortunately, it caught fire. So what is the solution? This is a global problem. So what happens is, so I hope you understood the problem. Two SPDs are stressed with 440 volt or 400 volt for a longer duration. It can catch fire. One example of such an accident. You see, this is in a petrol pump. The previous day, the incoming breaker tripped due to some reason. So without checking the reason, they went and switched on the breaker. So this guy is standing there and he is telling the other fellow, okay, you switch on. So he is looking at it and he said that to switch on. Yeah. So the SPD blasted because there was neutral isolation and the voltage was high. The SPD blasted. Luckily, nothing happened to them. You see, courageous fellows, they ran away. And it's a petrol pump. Would be nice. So what we did, or what is included in the standard, is very important to understand. These kind of situations are handled with a parameter, a test parameter, which is called as, each of the SPD made in or complying to the latest standard, the SPD has to be subjected to 400 volt for 2 hours. You connect the SPD 2 hours for 400 volt. Now what can happen? One is SPD can catch fire. Next is internally. So it has got an internal thermal isolation. The next chance is this thermal isolator is disconnecting. That means SPD fails, but safely. So fail safe. The third case is it may withstand. So there are 3 cases here. The first is it may explode. The second is it will fail safe, or the third is it is able to withstand. Now only first two, the last two are accepted in the standard. The SPDs which is blasting is you cannot sell it. So that is unsafe. Now this test parameter has been included few years back. Fail safe or TOV withstand for 2 hours. When you buy an SPD, probably you can also look at this particular parameter and check whether the SPD is able to withstand this voltage or not. Otherwise, what will happen is not a transient condition, but because of neutral isolation, your SPD will blow. And then you have to replace it. Whereas if you go for an SPD with this TOV withstand, then you will get a much better life. So only these SPDs are permitted. For example, in India, we included this in the National Building Code. All SPDs should be able to withstand this particular parameter. Say, for example, 2 SPDs I am showing as a classic example. 2 models of RayCap. RayCap is a German company. We are distributing the product all over India and this particular region. But as I said, please note that our business is not only SPD, our business is SPM. So it is not like simply supply SPD and forget about. No. We have to analyze the situation. We have to evaluate. That means an engineer should go to the site. He has to evaluate. He has to make a report. Then select the appropriate SPD. Then install it. Check that whether the line lengths are within the limit or not. So it's a big job. Now there are two SPDs. For example, Protect T1H and the Protect T1. The difference is only that H, only one letter. So the first one is a TOV 120 minutes withstand, 440 volt withstanding SPD. The next one is fail safe. Fail safe in the sense SPD will fail. It will fail safely. It will not blast. So then the cost of, for example, this fail safe, let us say it is 10 rupees. The cost of the other one, withstand, maybe it's about 12 rupees. You know, price will be a little bit higher. So you have to consider those things. One of the important subject of SPD is its backup protection. What is backup protection? Backup protection means, I think I will close in next 15 minutes. It would be okay, right? We told up to 7. Yeah. So one of the important subject of SPD is its backup protection. Backup protection in the sense, as I said, the SPD will internally, it is supposed to create a short circuit, especially MOV, it will create a short circuit. Then internally, it has got a thermal isolator. Probably that will work. But if the thermal isolator didn't work, what will happen? It's a short circuit. Your building will have a problem. So what do? You have to have a backup, an additional protection. The purpose of this additional protection is at the end of life of the SPD. It is not for normal condition. At the end of life of SPD. End of life, nobody knows. It may be 2 years, 3 years, 20 years also. At the end of life of this SPD, this backup fuse should protect the entire installation by isolating the SPD safely from the circuit. That is how it is. Now, you can see here the backup protection is made in, for example, this is the circuit, parallel circuit. There is a fuse, for example, and in this case, the fuse is at the line. This subject is called as, the first one on the left side is called as, here in this case, you are giving priority to continuity of supply. Because once when the SPD fails, the HRC fuse, the fuse isolate the SPD from the circuit, your supply is continuous, priority to continuity of supply. The second one, once when the SPD fails, the supply is isolated. So this is called as priority to continuity of protection. This is a very important subject. For example, not in a normal life. Let's say you are thinking about, or you are designing a wind turbine. You know the size of the wind turbine, and probably you must have seen wind turbine. In a wind turbine, you wanted to protect its electronics. Which one you will prefer? The first one, priority to continuity of supply or priority to protection? Priority to protection. Because the first case, priority to continuity of supply, there is no SPD. The next lightning, your equipment will burn. You cannot afford to lose the equipment. For highly sensitive equipment, if you cannot afford to the failure of such equipment, you should go for the second one. Priority, you should give priority to continuity of protection. Continuity of protection in the sense, SPD is in shorted condition. It's internally shorted. So your line and neutral is connected. So there is no conducted surge into your equipment. Your equipment is protected. You should. Now, if you want the continuity of protection, continuity, priority to continuity of supply as well as protection, then you have to go for an SPD which is having sometime, multiple varistors inside. So these SPDs are also there. We didn't brought the sample. I hope this is clear. Now, I have put a picture. First of all, from the line, you have a HRC fuse, then you have the SPD, then from the SPD, there is a wire which is going to ground, the line and the ground. So the total voltage, as I said, the V residual voltage, that means this voltage has to be lesser than the withstanding level of that particular device. The line length has to be as short as possible. include the line length in the sense the wire including the fuse has to be as short as possible. Now, manufacturers, sometimes the users are always confused where to put the HRC fuse and how to select the HRC fuse, because the manufacturer has simply told that my device need an additional backup fuse if the line current is more than 125 amps. I hope you got it. The SPD manufacturer will tell that this device need a additional backup fuse, once when the line current is more than 125 amps. This is the statement from the manufacturer. Now the user should decide where to put the fuse. Whether he can trust the fuse at the line or you have to have an additional backup fuse. It's a very critical subject. Let us say, for example, you are giving priority to continuity of protection. And this is how it is. You have a 125 amps fuse. That is your backup fuse for your SPD. And in the case 2, you have for example, F1 up to 125 amps, there is no backup fuse. If the fuse is more than 125 amps, there is an additional F2. This is how generally the installation is carried out, because the manufacturer told that up to 125 amps, you don't need a backup fuse. So as a result, generally what people think is, okay, if the fuse is, let's say 100 amps or up to 125 amps, this additional fuse is not required. As a result, they go for the connection type F1, this connection type 1 on the left side. If the rating of the current rating of the circuit is more than 125 amps, they put an F2, additional backup fuse. Actually, this is one of the very complicated subject to decide. To simplify the subject, the user should understand whether he need continuity to supply or continuity to protection. If you need continuity to supply, irrespective of the line fuse, let's say for example 125 amps, irrespective of the line fuse, you need an F2 if you want continuity of supply. Otherwise, continuity of supply is gone. So this is very critical to understand. And the rating of the fuses F1 is to F2 is 1.6 is to 1. For example, one of the SPD which we have shown here, say for example, in the first picture, you are deciding continuity of protection. That means you have not put any HRC fuse for the SPD. So F1 is to F2, 1.6 is to 1. The HRC fuse for this particular SPD, let us say it is 125 amps. Now, if the rating of the F1 is more than 125 amps, then you definitely need a F2. So something like this, something like the second picture. What I will do is, I will not confuse you, because if I explain this subject without understanding, without thinking the fundamentals, you will be only confused. So better I skip this. Maybe we can discuss it in another day. So, there are several permutation combinations. So if we apply those combinations, then the situation is different. Also, one more important subject is, if you are going for a 4+0 connection, one moment. I've shown some of the connections, 3+1, 4+0. So this is called as 3+1 connection. Means from the line to neutral 3 SPDs, from the neutral to earth 1 SPD. And this is called as 4+0. That means from all the 4 current carrying conductors, there is an SPD to the earth. Now, as I said, at the mains incoming, the best way is to go for the 4+0 connection. But the problem is, if you have a TT system, you cannot trust these fuses, because in a TT system, fuses will not blow because the fault current is quite less. The fault loop impedance and those things comes into picture, which is even not addressed in the standards so far. So the best recommended way is if you go for a TT system, don't go for 4+0 connection, you go for a 3+1 connection, the previous connection. So this is good for TT network. But ensure that the line to neutral SPDs are always 440 volt TOV with standard. Otherwise, that SPD fails. So, and we have a small question answer session as well. Otherwise, most of the important subjects I covered. Now, one moment. I will just touch upon the SPDs, some of the models, for example. This is called as type 1 SPD, 100 kiloampere. I'm sure if I give the data sheet, you can read it very well. No need to explain too much. Similarly, another type 1 SPD where the current is only 50 kiloampere, the voltage protection level is 1.5 kV and so on. Another type of SPD. So basically, if you look at our catalog, you will be able to, or in our website, you will be able to find out hundreds of type of SPDs. So selecting the suitable one is, that is the engineer's job. So now let me go to the communication. One important subject. Most of the time, SPDs are installed without understanding whether it will work or not. Am I correct? Nobody knows whether there is a real surge or not. So what you should do is, you can also go for a measurement system. I'm just searching for the slide, one moment. Yeah. This is the surge measurement system. You can find it in this particular box. One moment, let me take it. So basically, this is a surge counter. Most of the time, customers ask, especially industrial, telecom customers, they ask, I have installed SPD, but I don't know whether there is a real surge or not. So this is a device, as you can see here, on the earth wire, there is a kind of a CT. And whenever there is a current flow, this device will record it. You can see the time, duration, and the number of counts, date, time, and the number of counts. So say, for example, Wednesday afternoon, 2 p.m., there is a surge. Maybe on the same day, maybe there are 20 surges. So all these things can be recorded. This becomes actually a very good tool for, to decide whether the SPD is really working or not, because SPDs are passive devices. Nobody knows whether it is in working or whether there is a real surge or not. And this device, the advantage is if the surge current is more than 50 amps onwards, it starts counting. Even with a very small surge, it counts. Similarly, lightning counter, I'm sure you are aware, this is not a surge counter. This is, of course, this is also a surge counter, current counter, but this has to be used for the external down conductor. External down conductor means you have a lightning protection system on the external down conductor you can use for it, whereas the previous one which I have shown is for the panel board. Then there are devices available. These are, okay, we call it as universal SPD tester. With this tester, you can find out the spark over voltage of a spark gap or the clamping voltage, 1 milliampere, or the clamping voltage of an MOV. So with this device, you can find out whether the SPD is really working or not. So we use these devices to test SPD. This is also a good device. Also, the one which I am showing is a leakage current measurement, because if you go for a 4+0 connection, there can be leakage current once when the SPD deteriorates, and that leakage current may create some other problem such as shock. So these devices can be used to measure the leakage currents. Especially these are required for, when we talk about a high-tech installation, a highly critical installation. So hopefully with this, anyway, I didn't touch anything about the SPDs for data and signal line. Of course, we have a big range of data and signal line SPD as well. Data line means your Cat6 or your you know what is data line, RS-232, RS-485 or Cat6. Similarly, signal lines 12 volt, 5 volt, 24 volt, 48 volt, like that. It's a big range of product. So, but basically with this, I will finish my presentation. Probably we can have a small question and answer session as well. Shall I stop sharing?
You can sit here.
Yeah.
Thank you very much. Now we are moving to the question and answer session. For moderating this session, we cordially invite Dr. Nilantha Sapumanage to the stage. Online participants also can put your questions in the chat. So we will direct those questions to our resource persons also.
It depends on others where you are. For example, if you are in a location where the isotonic level is, let's say, X, then this maybe you will be getting 20 years, 25 years. Whereas you are in a place Y, where the isotonic level is 3X, then the light probably may be reduced. So these devices basically integrates. After a little time, it integrates, and after some time it may fail. The average, in my experience, the average life is something between 10 to 20 years in the development condition, where the number of thunderstorm data could be about 40 to 60, 40 to 60. But I was told that there are areas where you have 120 lights per year. So that area probably the life is 5 years, 7 years. Okay.
Thank you, Mr. Gopuma. So it was a fantastic presentation. So before going to the discussion, I have a small question to ask you. Just to into this. I think diagrams I know that type 1, type 2, type 3 is there. So the type 1 and type 2 is well tested with the current impulses. Whereas the type 3 is 150 4 days in the test. Is there any special reason there? Because the last stability is very purpose to get the voltage, because finally it has to protect this SPD electron. There, the amount of surge current expected is quite low, very small. More than current, voltage is low. Very tight. Thank you so much. And let me do that. From the online participants. Can be I need to know whether the lighting has and whether I think there is a feel that you no. I think it's a passive system, so only better components. Test is recommended as a standard, which is nothing but the you should physically check there is no corrosion, and you should check whether the continuity resistance are within the limit. Let's say talking about 200 milli ohms, we have to test. So only physical check with primary ensuring that all there is no corrosion and there will be tight and intact. Otherwise there is no device to test. So but for example, we have a software. I mean, it's a very expensive software. Indian rupees is about 80 lakhs. So with this software, we can simulate. We do it for very critical installations, like some defense installations. Basically, for example, if you have an EMP, electromagnetic pulse. Let's say, for example, you have two buildings, and between the buildings, you have a communication wire, power line, and unshielded wires. So once there is a lighting in one building, it's effect on the other building, and if the lighting is on the ground, what happens? Those simulations are possible. Otherwise, after installation, testing is with a device. I think this question is about the ground system test. So that is we have to for
Yes, sir. The electrode resistance shall be, if you go for a type A electrode, see, earthing for lighting production, type A, type B. Type A, there are two methods of making type A. The first method is the standard will tell you a particular length, let's say 5 meters of wire horizontal. Each term you have 5 meters wire horizontal or 2.5 meters wire vertical. You put that value, you don't need to test it, provided that length is visible. The second method is parallelly you can ensure that the electrode resistance, probably you are using another technique. You should ensure that the electrode resistance is lesser than let's say 10 volt. So if you are going for the second method, type A, second method, then you should check the resistance once in a while. If you are going for a type B, then there is a difference. Also, the standard preferably the earth termination system should offer a resistance less than 10 volt. Those definitions are still debated. Sometimes we try to read it depending upon the situation. Sometimes we say that is not because sometimes we say we can do it. Okay. Hope for the answer is true.
yes, online patient to go there is an article here. And you the basic, is keeping the separate consumer box from the other with the higher advance.
No, you put the USB in a separate box, then you will be using wires to connect it, and then automatically your wire length will be more. And if the wire length is more, the USB is gone. Rather, what I recommend is, if there is no space in your existing distribution board, you will have the outgoing MCBs. Put those outgoing MCBs in a separate enclosure outside, and create a space and put the SPB inside the existing MCB units. That is the best.
There's another question I have to explain during the presentation. The second question I asked him, when you are actually experience for learning that, say for example, these are the yard line, probably wire bond or car or weld. He asked me whether that 30% has been additional protected.
There's a possible power. The experience of these incoming, whether it is protecting the power supply, it is feeding the power, for example, 20%. It depends on the situation, what we are talking. If they are expecting lightning current only through the incoming power supply, then of course, probably it is protected. If we are talking about the direct lightning strike into your building, then only the SPT and the incoming may not protect this item that we form outside the building. That is why we divide the building into various lightning protection zones. Zone 1, zone 2, zone 3. So whenever the power line crosses the zone boundaries, we are supposed to put the SPT.
Now from your house, power is going to an external, for example, a motor. That means your distributor load is on one also two and your motor is so zero. So I need that many also then it may go. It will go back. I think this is one of our extreme rule that they have shield on the data for the there is no way of reducing voltages due to the extended environments. I think that has been. So I think other than that, there is no much question from the from live system. So I think now again we can open the floor up to the our guest over here. Is there any questions? To clarify, it may be from the direct credit production or maybe from indirect credit production.
It's regarding how that you would say you use CE current transport for accounting purpose. Yeah, it's used for accounting. Yeah. My question is that the search prevails for very little time. Yeah, microsecond level. So you see, accurate that every using
It is certain. It is certain up to 50 hours of this API will be doing. It is able to download. And then internally it has got a this EV is not to energize the data. It is only to sense. Energization is done through a battery internal. There is a battery inside.
can it be used for the other instances to be compatible for?
No, any service. Any kind of service. Actually, that is not a normal operating system. It's a critical point for robust part. So I can test the multiple frequencies. Now, for example, if you talk about normal robot, if I would say we are talking about power frequency, 50 hertz. But here you get from 0 hertz to maybe 30 or 40 hertz. Huge range of frequencies. So the normal field will not necessarily for that one, but the over special CD for robust people, where captures the entire frequency spectrum of that. The special field. Any particular question from the audience?
You mentioned about pasta cable. Compared to other types, what are the five implications?
I don't want to answer with the pricing etc. But for your information, this Burma amount of SPD is used for very critical applications. And these SPDs so far, according to data in Germany, I think last year, 2 years back, before COVID, the time was they have sold around 16 million pieces. And so far there is no failure for almost 25 years, no failure. So the line we are talking is it's a different category also. Professional level, company professional line is also totally different. Price will be almost double different. Sometimes not double, little bit more.
It's stable,
Of course. It depends on how much you can afford and what do you want to spend. Especially now, for example, all over America, all the aviations and telecom, this 5G, everywhere this is big. Similarly, now recently, I think 4-5 years back, the German telecom, they switch over to this SPD. Because bigger SPD because of the wireless, they are used to they switch over to. So slowly, the telecom companies are switching over to these type of things. Yeah. Is there any additional questions? Especially, so you can ask, I mean, everything you want to ask, because you kind of go and everything. Here you have international expert over here. So you have clarified anything on the series or maybe Latin prediction, either direct or indirect. So don't sit down. it is representation. It is not every people know how to do it. You are ready to do it. You can very easy thing as a giving you can see alone. You become much because most of the time houses are not by outside arrangements. You know, they are kind of, technicians. Somebody not even technician level, they are just fixing. So are making it complicated to bring any unit that you development, which can be treated straight off. It's just a protection that not a regular protection, maybe it's okay.
And to comply to the standards and regulations, at least a type 2 SP and the main distribution board is mandatory. So even for small installation, without looking into this complication, the best way is to put a type 2 SP, which is not very expensive. So type 2 SP is the main distribution for normal person. But if you if you have a big device with a lot of electronics, then you have to go for little bit electronics.
There is no other question in the matter. I noticed that even now, the coming from the right, the lighting strikes from the main utility, so then it comes back. It also, now, can we protect that kind of area? Because right now, basically, we know the utility are working for when we something like a normal level when the other utility gets very well. All you have to do is like this house, you need to
Meters are the old mechanical meters or electronic? Now what you both are about. So normally, if the meters are electronic and if the lightning is coming through the power line, that meter goes up. That is the first one to go up. Parallelly, if the current is too high, then some of the equipment also goes up. So it is a good idea to put a type 2 in the distribution code because before we meter nobody is allowed to put that. The special regulations are in the way the regulator. In America, in Germany and most of the European nations, they have started putting the SPT before the meter. Means they have a special system, 60 milliliter calculator, and they distribute the SPT before the meter. Whereas for us, the better way is we can start putting an SPT before the meter is not out there, because it is a property after the meter.
one thing to clarify is said that. So, this is that the pixel is sitting over the lighting is done. So the pixels which are not, meant to protect from the lighting, it indicates that your wiring system has more leakage than the house. So therefore, more leakage in the system. That is why the pixels are going. So when the high voltage is coming to your house, so there can be multiple ways that it can reach to the ground. So there will be different current between the neutral and the line. So that is the effect that triggers the pixels to be like that. Not that is not providing any sort of lighting protection because pixels take in second very couple of seconds. For example, to support speed less than 70 milliseconds. But 70 milliseconds is more than enough to keep everything between seconds. So therefore, to individual pixels to give the protection as the world said, you must do at least for transport protection at the same time. One thing, if you have a own protection, then you should go for a class 1. Am I correct?
Yes, correct. Because this, for example, this RCCD or the step series, if the current is 5 times its reference current, say 30 milliampere and the actual current, the residual current is 150 milliampere, then the tripping time is about 40 milliseconds. But before 40 milliseconds, our lightning phenomena is gone. Maybe 2 times lightning current is gone. So that is not useful. These devices will trip because of the capacitive coupling or the leakages. So most of the time we have found that the RCCs are tripping after lightning, but majority of the cases because of the failure. Lightning current created a failure. Because of the failure, this becomes that is a good.
I think it was a very nice knowledge and I think if it is if there is no money qualification that we can buy up that is so much this is person and I think we can release it now. So thank you so much for coming over here already and driving actively contributing to the presentation and asking questions. Thank you so much for your
Thank you. Thank you so much. Thank you.
Thank you very much, Engineer Gopakumar and Engineer Nilantha Sapumanage. Dr. Nilantha is the Director of Inspectorate Division of UCSL, which is the governing body actually in Sri Lanka. Thank you very much for sharing your knowledge with us. And now it is the time to hand over our moment to the Chief Resource Person. I am cordially inviting Engineer Chamin Edirmuni, the Chairman of Electrical, Electronics and Telecommunication Engineering Sectional Committee, to hand over the moment to Engineer Gopakumar.
I have to make more collections out there.
Now we are reaching to the end of today's session. So on behalf of the ISL, we must thank Engineer Gopakumar, who is the resource person today, who is very good asset for the lightning and SPDs. Today we have gathered very good knowledge and very basic things also. Now we know the connection wire should be less than 250 millimeters. Otherwise, whatever the SPD you used, whatever the best, it won't work as we expected. So with that knowledge, we thank to Engineer Gopakumar and not only for him, Engineer Dr. Nilantha Sapumanage also. Thank you very much, you sir. And President of ISL, he guided and support us to conduct this session very well. And past President, Engineer Tilak Disilla, he was with us in the evening, and Engineer other past presidents also. And actually, this won't be a possible thing unless our sponsor, Quill Electric, had sponsored us. Thank you very much for your contribution. Our electrical working group altogether, including Dr. Nilantha, they had very good support to us. Our treasurer also there. Thank you very much for the organizing part. And we had a very good participant here, and we saw around 100 number of online participants also there. We had a very good session. So thank you very much you all for the participation, and we expect your contribution for the future events too. Thank you very much. Good night.